everyone. Welcome to the Carolina Weather Group. I'm Scotty Powell. We're happy to have you this evening. We have with us Stephen Pfaff. He is the Warning Coordinator Meteorologist at the National Weather Service in Wilmington, North Carolina. And tonight we're going to be talking about ocean hazards. The Coastal Weather Service offices issue several advisories and hazards and programs like that other weather offices don't. So when you find yourself on vacation or visiting the beach or something like that, you may hear something that's not familiar with you. So tonight we're going to kind of dive into that and kind of go through all of these unique and different advisories and program and hazard programs that we see along the coast. And Stephen, working in the Wilmington office, is the perfect person to go to that. He does a lot of outreach events. So happy to have Stephen on with us tonight. As always, if you are watching and you have any questions, feel free to drop them in the comment section. We'll be monitoring those throughout the show, and we'll direct you. If we don't know the answer, we'll direct you in a place that hopefully you can get the answer. So we, again, appreciate you watching tonight. We're going to be focusing on ocean hazards and the different programs that the Coastal Weather Service offices use throughout this vacation season that's coming up. So, Stephen, welcome to the show. It's been a long time since we've seen you, so I hope that you've been doing well. First question I want to ask to you before we kind of get into the meat of the interview tonight is, when I say warning coordinating meteorologist, for those who may not be familiar with the Weather Service terms, what is exactly your job there at the National Weather Service in Wilmington?
Yeah, great question to start off with. We love these long titles, but good evening, and I appreciate the opportunity to talk with the group, and some of these hazards that we're going to be talking about, mean a lot to me, and you never know with the information that we share who we can impact with our lives. We might be able to save someone's life based on the information we share tonight. So thanks, but thanks for having me. But warning coordination meteorologist, I am like the public liaison. I'll work with civic groups. I'll work with the academic community. I'll work with emergency managers and also internal operations too, making sure our warning program has the resources that we need and the information needed, provide training. So it's absolutely amazing to me, because one day I can be working with a group of second graders. The next day I can be giving a stand-up briefing at an annual hurricane exercise, to working with the power squadron, working with the nuclear industry. It's absolutely amazing how many people that are impacted by weather in unique and specific ways and have unique needs that we can learn about and be able to help them as best we can.
And I guess I'll go ahead and start off with our topics tonight. We look at ocean hazards, ocean and coastal hazards for what you do. And so we start breaking down into different categories as what is relayed to the public as far as warnings go, as far as safety concerns. And usually one of the things that sticks out the most is rip currents, because that one claims sort of the most lives on the beaches every year with rip currents and drowning. So I guess we'll start out with rip currents. Give us a little bit of explanation about what those are and what to look for.
Yeah, what a great one to start out with, because when you look at the data and look at all the weather-related fatalities in the Carolinas, rip currents lead the way for us. We have a lot of coastline. We have a lot of people that visit our beaches that aren't taught anything about rip currents, and the first day they go to the beach, they might get caught in one. So that's a challenge in itself. And in addition to that public awareness type of thing that we have to do, forecasting them is often a challenge too. So, rip currents, again, more than tornado fatalities, more than lightning fatalities, more than flooding fatalities. That's the number one weather issue for us, not to discount any of the other ones. Another interesting stat too, nationally, people often, when you ask them what is the biggest weather-related hazard, they miss it because you can't see it. You can feel it. It's heat. And, now we're heading into summertime too, and the beach season, and we need to be mindful of the heat issues as well. But rip currents, can be quite frightening to people, and they don't understand the process. I guess the analogy would be is, an electrician works with electricity, which is dangerous, but they know what they're dealing with. They've had the training. They know what to do and what pitfalls to look out for. Someone coming to the beach, like a lifeguard, knows where to find the rips, knows how to use the rips and how to keep people away from them. But the average person has no clue. And And some of the statistics that we have are quite frightening.
Right. I understand the lifeguards sometimes they have a direct line to NOAA service accounts across the WFOs around the coast of the United States. So they call in a lot of times when they see rip current just to verify that it's happened. But that's very sporadic. It depends on where parks are and where some of these swim zones are. So where can the public get this information?
Yeah, the best way to get the information, of course, all of our media partners have access and share that as well. But we have rip current threat graphics on our web pages. All the weather offices up and down the coast have them. But social media has been a great way for us to push information out as well about them. And we saw a case last year though, because we feel there's deficiencies. Last year we had Hurricane Lorenzo. The closest approach to the United States was 2,200 miles. Yet that hurricane led to more hurricane deaths compared to the other storms that year on the East Coast, and it was 2,200 miles away. So we're thinking we need to start treating these big rip current outbreaks, these huge events, maybe like we do with severe weather outbreaks.
Tell us a little bit about the risk levels that are involved with rip current forecasting.
Yeah, when we look at the forecast and we're looking at wave data, we're looking at the synoptic pattern as well. But anything that can pile water up into the beaches is one of the big keys. So it could be persistent onshore flow, like that southerly flow wrapping around the Bermuda High that goes right into our south-facing beaches, where you have mass moving into the beach. You have to have it stay in balance, so it's going to try and flow back out to stay in a state of equilibrium. So if you have a lot of mass moving in, we typically see that mass being transported out via rip current. So mass in, mass out. So days where we've got decent surf coming on, especially the long period waves from a hurricane swell, that really are the signals that we look for. And when you think about the longer the wave period, the farther offshore that wave is feeling bottom. So in particular, hurricane swell is very dangerous because now your surf zone, instead of maybe being 20 yards, these longer period waves are feeling the bottom 40, 50 yards out. So if a rip current forms in that surf, it's going to be, it could be as long as a football field, the rip current length. So there's a lot of things that we have to consider when we deal with these events.
What about the stats? What do the stats tell us on, like, say, demographically, where might these occur more around
and again,
the United States?
The Weather Service maintains statistics like you wouldn't believe about tornadoes and the EF rating and microbursts and all sorts of different things, because it's so important what you can learn from them. And with rip currents in the Carolinas, we've kept statistics since 2000. So we've got a pretty healthy database, unfortunately, a healthy database. And we've had, since that time, 143 people drown from rip currents in the Carolinas. And when we start breaking the data down a little bit more, what's really interesting is that 25% of the drownings are people that are bystander trying to be the good Samaritan. They see someone in trouble with a rip current, have no training whatsoever, go rushing in, and they end up drowning in that. So, a lot of times, classic call to action information that we've given has been about the person in the rip current, and we need to do a better job of messaging that risk to someone who's on a beach watching someone in a rip current. The other interesting statistics that we see are the demographics that are hardest hit are males between 31 and 50 years old. And, I'm in that demographic now, and mentally I might think I'm a little more physically capable than I am, but the reality is that I'm not. And 31 to 50-year-old males have kids, some have grandkids, so there's a better chance they're going to be at the beach with a kid who gets into trouble and has to go and make a rescue too. If females, it's a little bit younger. It's 31 to 40 is the biggest group there. And if I break down the males, it's really 41 to 50, but that big group there. But males are 5 times more likely to drown based on our statistics. And when you look at where people are coming from, about 84% of the drownings are people from inland areas.
That's exactly right. A lot of folks come here, they have no idea that there's several factors in play. In fact, another topic to bring up is longshore currents. We know that we have tidal swings here in the Carolinas up to 6 feet for South Carolina, even 8 feet down into Jekyll Island, Georgia. So that's about the highest tidal swing on the southeast coast, but it makes for some pretty nasty currents along the beaches, along with waves and the potential for the riptides. We talk about currents, right, and how strong these currents are,
Yeah.
and how does that factor into what your forecasts go?
That's a great point too, because every year it seems, especially when there's more of a lunar influence, the higher high tides, lower low tides. A lot of our inlets, you can walk across them during low tide during these more of these lunar astronomical ranges. So you got people walk across to an island and they're having a great time, not paying attention. The tide's coming in, it's going to come in quick in that type of situation, and then they can't swim back, or even if they can swim, they get caught up in that tidal current and become a victim that way. I mean, I've been at the Wilmington office 20 years, and I'd say there's been at least 20 of them easily 20 of them where it's a function of the tidal current in inlets where water is being forced through narrow areas and catching people off guard.
Couple more topics for me, and I'll pass it on to Dan. And we talk about some of the other factors on beaches, like sneaker waves or even meteor tsunamis from release of energy from storms that would cause some tidal event, right? So start with sneaker waves. That's usually like more northwestern United States specific to the Oregon or Puget Sound area.
We do get them. We have records of them, and even video of some sneaker waves. I think when Hurricane Irene, with off Daytona Beach with the pier getting swamped. The phasing of different wave energy or the spectral distribution of waves, and when they have constructive interference, if you can get a couple of them where they phase up just right, you might get an anomalously higher wave, the 1 in 1,000 wave, based on wave distribution versus what your average wave that's out there. And if the timing of these sneaker waves is just right, you might, if it happens on 4th of July versus December, the impacts are, it doesn't matter. It's like the F5 tornado going through open field versus an F0 going through a city. You have different results, even though it's the same impact, but different magnitude. But we've had fatalities from sneaker waves. In Myrtle, I think it was Myrtle Beach several years ago, guy caught off guard. Wave knocked him down and actually gave him a spinal injury as he was hit by that. It was just very powerful, sudden wave. But yes, I mean, they're mainly West Coast. I mean, you think about the West Coast, just the distribution of waves is phenomenal compared to what we see in the Atlantic Ocean. There's so many different wave swell systems that are out there, and you have a better chance for having that interference come into play. And you hear stories, people fishing out like on a ledge on the West Coast on a rocky shoreline, and you look over at them again a little bit later, and they're swept away and they're never found again. So it certainly is more of an issue there. The meteor tsunamis, we've had record of them, especially mid-Atlantic. Northward, you hear of some. You hear of the one down in Daytona, I think in 1992, was associated with the collapse of a tropical squall line. But I guess the best analogy I can say with the meteor tsunamis is if you're ever in the pool and you have a raft and you have it out in front of you and you're pushing up and down on that raft, and how long does it take before you start feeling wave energy throughout the pool? It's no different. These meteor tsunamis, it can be significant atmospheric changes or large scale area macro burst type of thing, and all that air pushing right down on top of that wave, and then as it releases and you start getting a longer period wave. Usually they result in not much in a way of wave run up or inundation. Usually get rough currents. There was I think at Barnegat Inlet, New Jersey, a few years ago, when that big derecho moved off the coast from like Midwest to the Jersey Shore and Delmarva, there was someone snorkeling in Barnegat Inlet, and on the backside of that derecho that went through, there was a meteor tsunami that caused everything to become real turbid and very rough currents. So that's I don't usually lose sleep over the meteor tsunamis. I lose sleep over the submarine landslide tsunamis that could be lurking right off. I mean, there's a history of them off our coast. But either way, that type of wave is the predictability is we have a long ways to go before we can do that. It's hard enough getting the significant waves right, 5 days out, let alone try and forecast a meteor tsunami.
Can you tell us a little bit about gale warnings and kind of what goes into those and how those are used?
We have weather systems that result in 34 knots to 47 knots of sustained winds, nor'easter or winter storm, maybe a strong gradient between two systems, non-tropical. Then that would be the warning that we issue for that. There's no sea requirement with that. Like small craft advisory is at least 6 foot seas in the Carolinas is the minimum threshold for seas. So that could be a swell that's from a distant storm that generates those waves. But more than likely, we're issuing a small craft advisory because we're seeing winds around 25 to 34 knots. And that's about the level it really starts making navigation dangerous. A 6 foot swell wave in the open ocean versus a 6 foot 4 second wave, a locally generated wind wave, big difference. You can have boats roll over with the higher frequency waves. They're very steep. We call them steep waves. Now that 6 foot swell coming in could be a hazard, especially as it starts shoaling. So around inlet entrances, so picture a boater trying to get out the inlet or come back in through the inlet. If you have those big swells coming in, they're feeling bottom, especially with a falling tide. Now you've got waves going counter to the current. They can be extremely steep, almost look like cliffs before they spill or plunge over. So we do have these deep water hazards as they migrate to the coast can create certain issues for us.
That's really interesting. And so our small craft advisories, are they changing to warnings? Can you tell us a little bit about the changings that are happening to that?
Yeah, there might be some. I mean, we're going through a hazard simplification where we're taking a look at a variety of products and trying to make it a little bit easier. When you look at the weather.gov map and you see all the advisories and hazards and warnings going on, I mean, sometimes the thing's lit up like a Christmas tree. So the agency has invested a lot of effort with social scientists, with core partners to try and find a better way. So we will see some changes with that. I don't know to the extent how small craft advisories will change. Gale warnings, I don't think we're going to have any changes. And of course, storm warning, when you have over 47 knots sustained, we would have that.
As we all know, with any sort of simplification of hazards or anything weather related, it has impacts on a lot of sides. So that's great to hear that the social outreach there's happening to try and figure out how that will impact everything. One more thing that I have to talk about as far as open water hazards are concerned, as far as the special marine warnings, what's the best way if I'm a boater, if I'm going to be impacted by these special marine warnings, what's the best way? Well, first of all, what is that, and how does that warning get established, and then how is a person that might be impacted by it, how do I find that and look for it and know that it's happening?
Yeah, it's a great point, and it is a challenge just because of limitations of coastal weather radio, cell phone connectivity, access to apps. When you're further out, when you're farther offshore, you're losing a lot of the ability to receive this information. So it's always important to know before you go. If there's a day that we're calling for all these thunderstorms, it's not worth it, live to play another day type of thing. So right off the get-go, we've lost boaters to strong to severe thunderstorms before. Knock on countertop, not lately, but it has happened where people are taking risks and get caught by quickly evolving storms like even that MCV that went through yesterday morning here. I would not have wanted to been anywhere near a boat with that coming through. But when we do have something like that come through, if we anticipate winds over 34 knots, then we would issue a special marine warning, or if it had water spouts with it, or large hail, because large hail in the open ocean you could break the windshields on the boats and things like that too. But usually they're issued for 34 knots or higher sustained, or I'm sorry, any gusts 34 knots or higher, and any potential for a water spout. As soon as we send the information out, it will play over the weather radio, and a lot of the VHF bands on a boat radio, you can see or hear those messages coming across. Now, some boats have radar on them, but they're not the right band to interpret weather data when they're twirling around. Usually, if there's a big thunderstorm target, the band that the marine radars are used, you might only see the edge of what's out there. It's not powerful enough to penetrate into the storm, so that really doesn't provide much in any way of value. But I think there are some providers via satellite where you can get information. But it is a great question, because you need to be connected to that environmental intelligence if you're going to be in an area where you're at extreme risk. You can't just 30 miles offshore, you can't just seek safe harbor in 10 minutes. You got life and death decisions to make, which is why we say avoid it if at all possible. Go a day when there aren't thunderstorms in the forecast.
Stephen, a couple more advisories to cover with you, and one of them is one that we see almost monthly pretty much in the Carolinas with the lunar cycles and onshore winds and other factors. So the first one we'll talk about is coastal flood advisories. What exactly are they, and what should the public be looking for when they're issued?
Yeah, that advisory, unfortunately, we're issuing more and more frequently, and there's a couple reasons for that. With sea level rise is one issue, but there are also parts along the Carolinas where there's actually subsidence going on. So the land is sinking. There's parts where the land is rising a little bit, and there's parts where it's sinking too. You can also have changes to the local hydrology, like they did a lot of dredging in the Cape Fear River. So between the subsidence, sea level rise, and the dredging, our number of coastal flood advisories has gone up incredibly. Now, the thresholds for where we, before we decide to issue one or not, vary based on the datum that's related to that location. So you can't apply 5.5 feet mean low or low water at every coastal station because their datum varies. So what we have done, worked with a hydrologist, we've done coastal flood surveys, get out there when there is flooding going on and observe the impacts. We call that E19 data. It's mainly for rivers, but we do have E19 data for coastal locations as well. And once we know what the level is and what the impacts are, now we have a good database and we can put good information into a coastal flood advisory based on the levels that are predicted to occur.
So moving on to the next advisory, and I think our last advisory for the night, high surf advisory. I think this is one that sometimes, especially for beach visitors, not necessarily residents, but someone who's coming from inland areas, it's easy to underestimate a big surf. 4 feet may not sound that big, but all of a sudden you get out in the water and 4 feet is a heavy wave. So tell us a little bit about how to be safe during the high surf advisory.
Yeah, and that, you mentioned the heavy wave, you can feel the power on those days where it's really moving like a washing machine out there, and unless you really know what you're doing, that's something that should be avoided. Just between the plunging breakers, potential for spinal injuries, those sorts of things, and it makes you hard to see too. So you get into trouble, and you're in this rough surf or high surf, you might be hard to spot, or even hard to get someone's attention if you're in the perspective of being in the water. But some of the thresholds we use, I think, are about 6 to 8 feet breakers we get, depending on how clean the ocean is, depending on the wind. Surfers get excited when we do high surf advisory, especially if you get a light offshore wind and it cleans it up a little bit. It doesn't look like a washing machine, but it's still powerful and dangerous if you don't know what you're doing. The thresholds vary up and down the East Coast, but our wave climatology, it's not like Cape Hatteras, like Wrightsville Beach is we get decent waves there, but typically not like you see it at the Outer Banks. And then you get in the Long Bay, Myrtle Beach, you got to get the wave energy coming in the right direction for us to issue a high surf advisory. The frying pan shoals block a lot of that easterly swell, where Wrightsville Beach might get it, but Myrtle Beach won't. So it's really unique to the shape of the coast as well, but it's a great point to talk about.
Move to my last question before I hand it off to Scotty. Chemical and oil spills, I'm probably going to see this a little bit less frequently, but if you're out in the water, it's certainly still a hazard if it's ongoing. Where is this a problem? Is it a problem in the Carolinas? And if so, how can we be aware that it's happening?
Well, it's frightening how many tankers bring all sorts of scary things just off the coast. And the 21 years I've been in Wilmington, there have been a couple close calls, especially I think one time a barge with maybe number 6 broke loose off of Cape Fear, and luckily in a storm, and luckily they were able to get a hold of it and make sure it didn't cause any problems. But with oil rigs, it isn't a big issue for us because we don't deal with any. I mean, more for the Gulf Coast. I mean, I'm more concerned with maybe a ship with hitting a shoal or a collision, sea fog event, and you got ships carrying xylene or some other terrible chemical that collides with another one, and now we have to deal with the decision support thing, working with emergency managers. And that's why, I mean, it doesn't matter. It could be severe clear weather. We always have to be ready, and most of these events are a result of some mistake and when we talk about oil spills. But at least what I'm proud, part of NOAA is the National Ocean Service, and they have scientific service coordinators that have responsibility for each part of the coast. So it's important for us to have a good relationship with the coordinators in our area, which we do. So we've exercised with the Coast Guard, going through their incident command training, doing their oil spill exercises, and working with the scientific services coordinator, because it's all about knowing who the players are, not just showing up going, okay, what do I do? How can I help you?
These are hazards that have come about from out in the water. What about any of the hazards that have originated from within inland? I think one of the biggest examples we've all seen is after, I believe it was Hurricane Matthew and maybe Florence as well, seeing a lot of stuff being carried out from the rivers and satellite imagery showing it making its way into the water. Was there any sort of response to that as far as keeping people off the beaches for a period of time, or any sort of hazards associated with that might happen again the next time we get a big hurricane? It's
a great point too. There's the debris hazards too for boaters. There's the biological type of hazards too. There's a lot of things washing down pollutants that, I think the rule of thumb is, you really don't want to be messing with the water after a hurricane or a huge flood event. Bacterial counts are high, the other pollutants that are out there, give time for it to flush out. And what's amazing is that after a hurricane, the fishing is usually tremendous along the waterways and just offshore for that month or two afterwards.
One thing that very photogenic around the Carolina coast, and we see these events happen, are water spouts. So can you talk to us about maybe the conditions that warrant to these water spouts? And I know you guys monitor these and you give out surf hazards. It's kind of like a beach day forecast, and you give out water spout threat, lightning threat. So talk a little bit about that forecast you give out, but also the conditions that are really able to produce these water spouts off the coast.
Yeah, and I got to give props to one of our lead forecasters, Tim Armstrong, who developed this water spout risk, where he went back and looked at a catalog of events that we've had over the years and found some really interesting information about instability and actually lack of shear type of environment, but with the boundary in the area, like a land breeze or some other boundary that might be stalled up there. So it was, we think, people see a water spout and they might think it's it's the classic tornado, and some of them are, like the big Myrtle Beach tornado, July 6th, 2001, I somewhere around there, was actually like a classic tornado that just happened to ride down the beach and move into the water. So some are classic tornadoes, like even the tropical cyclone tornadoes are more of the classic type versus your regular water spout. So, but every summer we get the right instability in place. We get light winds through the atmosphere with that boundary there, and we get you get funnels that come out, and some of them can be in absence of any rain, and then just lollygag around. On occasion, maybe once every 3 years, we have to issue a tornado warning for one that's moving closer to shore. The last one we had move ashore was near Myrtle Beach, near the Ferris wheel a couple of years ago. We had one at Carolina Beach back in 2011, the week before Hurricane Irene, I think it was. We had to do a tornado warning for that. And they don't show up on radar all that great. We use some products like Spectrum to really see some of that smaller scale turbulence that's going on associated with the funnels. They're usually very narrow, so with the beam spreading out from the radar after a distance, the circulations sometimes are too small and they don't get captured by the beam all that well. So it's important for us to have partnerships with the Coast Guard and the boating community, and lifeguards as well, to see them and get that information back to us so we can take action, unless it's a little bit bigger one that shows up on radar.
Well, Stephen, we've certainly appreciated this all useful information as our listeners and followers head out to the beach for some relaxation time, and we hope tonight's program will help you all who are listening and watching to know these hazards, that on a sunny beach day, there's still things that we need to pay attention to. For folks who may be coming into the Wilmington, Myrtle Beach, the southern North Carolina coast, the forecast area that you cover, Stephen, what's the best way to follow this information? Do you have a section on your website? I know you mentioned social media. Where can our followers and listeners find that info at?
Yeah, each office on their webpage, like Wilmington, weather.gov/ILM, or Charleston is weather.gov/CHS. We have a surf zone forecast link on the webpage there. It's not as pronounced as we'd like to be. It's usually towards the bottom, but there's good information there. But I would recommend tapping into us on Twitter or on Facebook, and especially with Twitter, because some of these beach hazard statements that we issue for when the risk is moderate or high for rip currents, I mean, you would get that information that way, and you might learn about some other things too.
So if you're heading to the beach, make sure you follow National Weather Service Wilmington, Charleston, Morehead City, I think, and I think that's the three. Yeah.
Springfield, Virginia has a little bit of North Carolina.
Yeah, so follow those accounts if you're heading to the beach. That way you're up to date on all that's going on along the ocean. So, Stephen, thank you for your time. We hope that you have a great rest of the summer. I know hurricane season is lurking and around the corner, and you're getting prepared for that. So hopefully it'll be a quiet season for you. We appreciate you joining us tonight.
You're welcome. We can use the break, so I'll take it.
Definitely. So thank you guys for watching the Carolina Weather Group. We'll see you next time. Have a great evening.